Hello and welcome to the channel Understanding Concepts of Physics. Today we are going to discuss this one of the numericals from projectile motion. So the question is in front of you. You can pause the video and go through the question. There are two datas given. One is the angle of projectile. So if this is my projectile, they have given that the angle of projectile is 40 degrees and they have said the initial velocity is 30 meters per second. And they have asked us to find out horizontal range. So where is it going to fall, the horizontal range. They have also asked what is the time of flight, so that is the time required to go from initial to the final point, and the maximum height, that is this h. So these three things are asked. The given data I have represented in the tabular form. Theta is given as 40 degrees, initial velocity is 30 meter per second, so everything is in proper system of unit. They have asked us range, the time of flight, and the maximum height. So let's go ahead. So the formula for range is u square sine 2 theta by g. In any of the grade 11 book you might find this formula, u square sine 2 theta by g. In case if you want the derivation of this, you can just comment me in the section, so that I will just derive it in a separate video. So u square sine 2 theta by g is the formula for range. U is 30, theta is 40, and this is 2 as it is. So 30 ka square is 900, 40 into 2 is 80. Now g is 9.8. Now sine 80, either we find it from the table. So you just have to see the table of sine, and in front of 80 degrees you will find a number, and that would be 9848. Sine ka value is always between 0 and 1, so you will get 0.9848. In case if your board allows calculator, then yes, this is something very easy to find out. But in case if your board does not allow calculator, if it allows logarithmic tables or sine tables, then you find this sine 80 from from the table. Then you multiply this and divide this by 9.8 and you get 90.44. In case if you are given log books, apply log. Wherever there is a multiplication, there should be a plus. Wherever there is a division, there has to be minus. If calculator is allowed, then again calculation would not be a problem. 90.44 meter is the range. That means it is going to fall around 90.44 meters. So that is approximately 90 meters. So this is the first thing which we have found out. Now we are going to the next one, that is the time of flight. Now time of flight, the formula for time of flight is 2u sine theta by g. U is given as 30, theta is 40, and g is 9.8. Sine 40, again find it from the table or calculator, whichever is allowed for you. Sine 40 is 0.6427 divided by 9.8. Calculation of this part is either from logarithms or by calculation. You can also like cancel by your regular math, your 7th 8th grade math, and the answer comes out to be 3.935, which is approximately 4 seconds. So the projectile will be in air for almost 4 seconds, and after 4 seconds it is going to land on the plane. Now this was the second thing. Now we are going to the third part, that is the h, that is the maximum height. Maximum height is given by u square sine square theta upon 2g. This is the formula for maximum height. So u is 30, theta is 40, 9.8. Now 30 ka square is 900. Sine 40 is 0.6427 the whole squared. So 6.427 the whole square. Make sure that you're mathematically you are sound, and it's not like you should not be squaring 40 and then taking a sine. That will not be a proper way of doing. First you find out sine 40 and then you square it. 2 into 9.8 is as it is. Again, solving this part is either by logarithms if your board allows, or by calculator if your board allows, so and so. Solving this, I'll get 18.96 meters, which is approximately 19 meters. So when the projectile is launched, it is going almost like 19 meters in height. So this is all about The first the numerical, this has been shared by one of my students. So thank you so much. In case if you like the video, subscribe the channel. Bye.